Okay, thanks for the introduction. I will be talking about our work on the data flow sandboxing, and I'm Lucas from the Technical University of Darmstadt. This was a joint work together with David and our advisor Matthias Hollick. So basically, the motivation for this work was when we thought about, I should stay in the video frame, when we thought about how mobile apps work these days. So for example, you want to download some app and you might be conscious about what kind of data this app collects and what kind of data this app might extract. And basically, we've had this following scenario in mind. So you might want to use some audio recorder. And this audio recorder should work fully offline, right? So it can access the microphone, you can record audio data, and this is something that you're happy about. This is the primary function that you want to be using. But on the other hand, there might also be secondary functions that might be involved in the app. For example, the app can also download stuff from the internet, and this might be legitimate stuff. For example, they might download configuration data, the app might also want to show ads, stuff like that, and you might be fine with this. But now the big problem is that the app now has this internet permission, and the app has the permission to access your audio data, which means the app can do whatever it wants, and it can just upload everything to the internet, and you can't do anything against it. Now you could argue, okay, why do I install an untrusted app at all? If I don't trust the developers, why do I use this app? Could I not just use another app? And I would argue that in the future that we're heading into, a lot of critical functions are hidden behind or gated behind apps. If you think about public transport, you might need the app because otherwise you are just basically stuck reading you're stuck navigating this without the app, and you might not even be able to buy a ticket. Or think about your healthcare provider. You want to upload documents, and the only interface that they offer is by an app. So basically, this led us to the question: how can we fix this underlying problem? And to maybe restate the underlying behavior, and I think most of you are probably deeply familiar with this already, but how it works on Android, and it works also similar on iOS, but we build our ecosystem around Android, so we stay with this example of Android. So you have this app sandbox, and this is already quite nice because different apps cannot directly exchange data if they don't want to. So each app is running in a separate sandbox. And then you have this operating system service that gates permission protected data. And if now your app wants to record audio data, it might request this from the operating system, and it basically says, okay, I want to record audio. The operating system then checks if your app has the required permission, for example, in this case, whether the app is allowed to access the microphone. And then the operating system will just return the data to the app, and now the app can do whatever it wants with it. And we basically argue that in this step, the user mostly loses all control over this data because they had the choice to say, I want to allow microphone access, but they don't have any choice over what happens now with the data. And this is basically what our system fixes. And basically the idea how the system works is that in Privacy Box, we add a new entity. And this entity are privacy or permission sandboxes. And here the idea is that parts of the app can now run into these permission sandboxes, and each permission sandbox has an associated permission. So for example, in this scenario here, you would have this permission sandbox that has the microphone permission, and you have the second sandbox that has the internet permission. And the first step in our system is that we fully remove all access to normal permissions from the apps. So this basically means that the app sandbox itself can no longer access the permission protected data from the operating system service. Instead, only permission sandboxes are allowed to access this kind of data. So basically, how would this look like? Now this permission sandbox could request the data from the operating system service, and then the operating system returns this to this permission sandbox. Now this permission sandbox can perform arbitrary computations on this data, but by enforcing the isolation of the sandbox, this data cannot leak into either the app sandbox or the other sandbox. Okay, good enough, but I mean, now you might wonder, what can we do with this data now? Because this seems fairly useless. We can do arbitrary computation, but it's stuck in the sandbox. So that's why we also allow sandboxes to return data, but only in the form of an opaque handle. So this would look like something like this. So you basically return this opaque handle, and now you have the app sandbox has this handle which refers to the data, and the data is still kept by the operating system. So the app cannot access this data directly, but it has this reference to the corresponding data. And now what the app can do is it can pass this data into another sandbox. For example, here in this permission sandbox that has the internet access. And what now can happen, like now if you want basically to perform some operation that might need internet access, for example, the user might want you to upload something to the internet, then you can try to dereference this handle by going into the operating system service. And then what now happens is that you get this consent prompt. And now, as you can see here, the app now has to ask to basically access the microphone data and send this to the internet. And what I want to highlight here is the difference to the previous permission system, because now the difference here, the important distinction, is that now you say, I want to upload this microphone data to the internet. You basically only give permission to this specific data flow, and the app can still not, for example, save your microphone data to the local storage. And this is basically the point where we are trying to give back user control. Next up, you might wonder, okay, but I still want to show user interface elements. How would that work? And for that, basically, we use remote rendering. And for that, if you imagine this app, and this app might have this overall view, which is still owned by the app. So you have this app sandbox that owns the view. But you might have now these subparts of this main view, which are rendered by different sandboxes. So for example, one sandbox might render this content down there, and the other sandbox might render different content that, for example, has to show the location data on the screen. And we implemented this during using remote surfaces, which are supported by Android. And they are basically managed by the Surface Slinger, which is the privileged Android daemon that handles, or system service that handles this rendering. And this basically guarantees that the app itself can never read any of this content drawn onto the screen. And because this also allows to forward input data, you can basically have private rendering within the main app sandbox and within the main app view. Okay, and with that, I want to basically conclude with our takeaways. So what we basically did was to implement pbox, which we used to enforce data flow sandboxing, and we implemented this as a practical measure to give back control to users. And we implemented the whole thing on top of Android ISP 15. So this basically means we have a full prototype that you can try out, where we have to have implemented a sandboxing mechanism, and we also have adapted some sample apps that you can basically use within the system, and where you can try out these security guarantees that this affords you. We also did some benchmarking on that. Obviously, we didn't have the time to cover this in the 10 minutes, but if you're interested in that, you can also find us in the back of the room, and we can show you. We have some figures on the paper, on the poster, of course. You can also message us at either Becker or the Breuer at Darmstadt.de, and this is how my poster looks like. And if you're interested, just talk to us, and you can also find the source code and the artifacts at this link. Thank you very much.